Welcome to the walkthrough video for Lab 7. This week we're going to be working on subqueries, which are among the more complicated topics in this course. So let's look at the first question. It's asking us to show the invoice number and total price for all invoices which go to customers from Oregon. Let me start by explaining the concept of a subquery. So I'm going to start with two tables that are related. So here's the ERD for the Fired Up database, and I got this from lesson 6 last week. You'll find the ERD there. And basically any link that we have in this diagram can be used as the basis for a subquery. So for example, if I want to know the customers who had a particular invoice, I can write a subquery on customer that I use a main query on invoice. Or if I want to find the, let's say, employees who built a particular stove, I can write a subquery on employee and write a main query on stove to get stoves that were built by a particular employee or set of employees. Or I could write a main query on employee that uses a subquery on stove to find all the employees who built a subset of stoves. Or, for example, stove repair, repair line item to part to PO line item, and so on. Any of these links you can connect using a subquery. So let's start with finding all the employees who made a sale. So first I'm going to find all of the invoices, and then I'm going to find all of the employees that were listed in those invoices. So I have on invoice as a subquery, I have the foreign key emp ID, and then in employee, I have the emp ID field. So if these two things match, then I know I have an employee who was in an invoice. So let's go ahead and do that. We'll start by select FK emp ID from invoice, and if I execute this query, here are the emp IDs of every employee who appeared on an invoice. And I can make these distinct. And so here's the shorter list. Now if I wanted to find all of the employees who are in this set, I can select star from employee where emp ID is in the set 1, 4, 5, 6. So here are all the employees who sold a stove. Now the tricky part is that instead of having to write this as two separate queries and then manually repeating all the information from the first query, I can actually stick this whole query inside of here. And I'm going to tab this over to show that it's a subquery. And now if I execute it, I get the same results back. I don't need this distinct anymore, so let me get rid of that. And I still get the same results. So this inner query, the subquery, is returning a set of employee IDs, and then this outer query is checking the employee IDs to see if they're in that set. And I can do that with any two tables that are linked in the ERD. I can also put restrictions on either the inner query or the outer query. So let's look at all the employees, let's look at all the invoices again. Select star from invoice. And for example, I see the total price here. So if I wanted to only return employees who had sold more than $1,000 in total price on an invoice, I could add where total price greater than 1,000. And I only get back one employee ID. Can do the same thing in the subquery here. I can say where total price greater than 1,000. And now I only get one employee coming back, Fred Bailey, employee ID 4. So I can put restrictions here, and I can also put restrictions in the outer query as well. So this one is asking for invoice number and total price for all invoices which go to customers from Oregon. So looking at the ERD, we want the outer query to be invoice, and we want the inner query, the subquery, to be on customer. So we want to select all the customers where the state province is Oregon. This will return a set of customer IDs, so select customer ID. And then we take that set and we write an outer query that selects the invoice number, what else, and total price for all queries where FK customer ID is in the set of values returned by the subquery. So the basic structure is just like this query, except you're going to select only a few fields instead of everything. You're going to search the invoice table looking for FK customer ID in customer ID from customer where state province is Oregon. So don't forget to only return the fields it's asking for, invoice number and total price, and also don't forget to order by invoice date. Okay, the second problem is asking for serial number, manufacture date, and color for all fired now stoves which were not built by Mike Wentland. Make this a little smaller here. So let's look at the ERD, and we want the serial number, date of manufacturer, and color for all fired now stoves. Yep, so match the type to fired now that were not built by Mike Wentland. So first we want to start with the employee table, and we can tackle this two ways. We can either find all the employees who are not Mike Wentland and then look for all the stoves that were built by those employees, or we can find all the employees who are named Mike Wentland and then find all the stoves that were not built by those employees. Either way will work. So let's instead look at the supplier and purchase order, and let's find the purchase order number, order date, and terms for all suppliers that are not named 3M. So let's look at the supplier table and the PO number table. Select star from supplier. Select star from, what's it called again? Purchase order. And let's look at that. So the purchase order table has FK supplier number, and the supplier table has supplier number. So we want to use the purchase order table in our subquery. I'm sorry, I said we wanted to find the PO number, order date, and terms. So this has to be our main query. So in the subquery, first we want to find all the suppliers who are not 3N, not 3M, 3N. And then we want to find all the PO numbers from suppliers from that set. So let's go ahead and select supplier number from supplier where, say, name not equal 3N. So this gives us the supplier numbers for all suppliers except 3N. And then this is going to give us all of the purchase orders for those suppliers. So instead of this ... I want to include the set of supplier numbers. Copy that and paste, and then tab over. So here are all the purchase orders from suppliers who are not 3N. Now I could also, so let's see, hold on. So I have 15 lines coming back. So I can also do this the other way around, which I can find all the suppliers who are 3N, return those supplier numbers, and then look for all the purchase orders where the supplier is not in that set. And I should get the same results back here. So yes, I got 15 lines coming back, which is the same number of lines. Okay, so the question also asks you to display serial number, manufacture date, and color, and to format the date using month, day, year, rename all the columns, and sort in descending order by manufacture date. So instead of returning all the columns, let's return PO number and order date and terms. And I'm not going to show you how to reformat all of these columns because you should know how to do that now. But I will go ahead and convert the date. So it's asking for month, day, year with slashes. So we'll use convert, and then we'll turn this into a character string that's 10 characters long. And we'll use date format 101. And then we'll give it a name, order date. Okay, so let's go ahead and execute this query. So we're sorting, actually we forgot to sort, so let's go ahead and sort as well. Now notice you want to put the order by in the outer query where the final return results are going to be ordered. If you put it on the inner query, it's not going to do anything at all because it's still going to, it'll order these results, but then you only have a set of supplier numbers and it doesn't matter if they're ordered or not. So be sure to put the order by in your outer query, like so. And now these are ordered by order date. We have month, day, year. And don't forget to format and rename the PO number and terms field. Okay, in question 3, you want to return invoice number, part number, and quantity for invoice lines, which are for parts which have a cost less than $150. So it's asking for the invoice number, part number, and quantity. Part number and quantity for all parts that have a cost less than $150. So your inner query is going to be finding all the parts where the cost is less than $150. You're going to return the part number, so you'll have a set of part numbers coming back. And then the outer query is going to look for in line items where the FK part number is in that set. And then for those records, you'll be returning invoice number, part number, and quantity. So instead of doing that, let's do PO line items. So PO line items for parts that cost more than, say, $30. So we're going to find all the parts that cost more than $30. Then we'll find all of the PO line items that include those parts. And then we'll return PO number, part number, and quantity from the PO line item table. So let's go ahead and select star from part and select star from PO line item and see what we have. So we want to find all the parts where the cost is greater than, well, these are all pretty low cost parts. So let's use greater than 3 instead. So let's find all the parts where the cost is greater than 3. And then this will return a set of part numbers, like so. And now we want to find all the PO line items where FK part number is in that set. So we want to copy that query and replace here, tab over. So here are the PO line items where the cost is greater than 3. And then we want to return the PO number and the part number and the quantity. So invoice number, part number, quantity for all invoice lines which are for parts that have cost less than 150. Use correlated in subquery to identify the parts. So if we want to use a correlated query, instead of using in here, what we're going to do is we'll use exists, and then we'll find the parts where both the cost is greater than 3 and the FK part number equals part number. And we do that instead of that. So basically what's happening is that we're going to go through the PO line item table one record at a time. And for each record, it's going to run this subquery. It actually is more efficient. The search engine is more efficient, but conceptually that's what's happening. It's going through one line at a time. For each record, it's looking at the FK part number, which is in the PO line item, and it's matching it to part number in the part table. So either we're going to find one or more records where the cost is greater than 3 and the outer FK part number matches the inner part number, or we'll find 0 records coming back. If we have 0 records coming back, then exists is going to be false, and so we won't get that record in the final return results. If we find one or more records, then exists is going to be true, and we will get that line in the return results. So we should end up with the same results as we have now. We have 20 lines coming back. Let's see if we still get 20 lines. And we do. So we get the same results coming back this way. But this is a correlated query because now if I go ahead and I copy the subquery and attempt to run it on its own, I get an error because there is no FK part number in part. This subquery can only be written inside of a query that includes a table that has an FK part number field. So that's why this is considered a correlated subquery. So question 4 asks for all customers that have not returned stoves for repair using a correlated subquery. So going over here, let's look for all employees who have not built stoves. So our inner query is going to be going through all of the stoves and looking for the emp ID in the outer table matching FK emp ID in the inner query. And then if you find a record where the employee has built a stove, then you're not going to include that employee record. So we're going to use not exists so that we don't include the employee if the employee ID is in a stove. So let's go ahead and start by looking at employee and stove. Select star from employee and select star from stove. And then basically for each employee, we want to go through one employee at a time, say, was there a stove repair by this employee? If there was, then we don't include the record, and if there wasn't, then we do include the record. So the inner query is going to look like where fk empid is equal to empid, and the outer query is going to look like select star from employees, where not exists, and then the subquery. It's employee. There we go. Right. So for the first employee, do the subquery, see if there are any stoves where the employee ID built that stove. If you find a record, not exist says don't include the record. If you don't find a record, not exist says do include the record. So here are all the employees who have never built stoves. And it's excluding employee 8 and 9, Mike Wentland, and I forget. So it's working correctly. If we wanted to write this as a correlated query, select fk empid from stove. So this is all the employees who have built stoves. And then the outer query is select star from employee where empid is in, not in, that set. So we should get back the same records as we got before, and we do the first 7, not 8 or 9. So basically you can write the query either way. This one is asking you to write it this way using a correlated query, which I think is a little bit harder, but either way you'll get the same results. So you might want to write it first as an uncorrelated query, make sure you know what the correct answer is, and then rewrite it as a correlated query and make sure you're still getting the correct answer. So you're going to be looking for customers that have not returned stoves for repair. So once again, look in the stove repair table, find all the customers that have made a stove repair, and then look for customers where the customer ID is not in the set of FK customer IDs. So that's your uncorrelated version, and then for the correlated version you're going to go through the customers one at a time, and for each customer ID you're going to be looking for whether there's a stove repair where the FK customer ID matches that customer ID. So now we want a correlated query that finds invoices which contain charges for more than one of the same part using quantity. And we want to return the invoice number, date, and total price. So looking at the ERD, the date and total price are in the invoice table, and the quantity is in line item. So we want to find, for each invoice, we want to run a subquery that looks for an invoice line item where the quantity is greater than 1 and where the FK invoice number matches the invoice number. And let's do a different query. Let's look at the part and PO line items again. So I'm listing purchase order. So we'll look for purchase orders where the quantity in the PO line item is greater than 1 instead. And so we'll return the purchase order number, the order date, and the terms. So let's go ahead and write this first as an uncorrelated query. And select star purchase order. And we know that purchase order is going to be our outer query, and that PO line item is going to be in our inner query. So we want to find the ones where the quantity is, these are all pretty high, so let's make it greater than 50. So we want to find the PO line items where the FK PO number matches the PO number and the quantity is greater than 50, and that's going to be our inner query. So FK PO number and then our outer query is going to select POs, purchase orders, where the PO number is in this set. So here's the correct uncorrelated query. We have 12 records. So now let's do the correlated version. So select star from purchase order where exists select star from PO line item where quantity is greater than 50 and PO number in the outer query is equal to FK PO number in the inner query. So for each record in purchase order, check to see if there's a PO line item where the quantity is greater than 50 and the FK PO number for this PO line item matches the PO number for the outer query. And we should get the same results back. I think we did. So that's an example of that query. Now, this one asks you to do the date in year, 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 month, month, day, day format. If you don't remember the code for that, I mean, who does? Go ahead and do a Google search for convert MS SQL, and that will take you to the page for cast and convert. There's a little table there. It will look like this. Hold on. Yeah, so here's the page for cast and convert, and it shows you all of the handy-dandy codes. So go ahead and look that up. And be sure to format all output.